All right, so I'm giving a little bit of homework help on the angle relationships assignment as well, because a couple of kids have reached out for some assistance on that. So here we go. Pardon my camera. I'm just trying to get it so that I can see everything. All right. Okay. So again, this is angle relationships assessment. This is due in Skyward. Oh, I want to say it was due tonight, but I think I extended it to the 11th or the 10th by 11:59 p.m. since I was out today. This is Miss Starling. All right, sorry about that. Okay, so 4 triangles are shown, and what they're showing is the remote sum. This is what they want you to understand and display here. So they're showing that the remote sum of these 2 angles, these 2 angles, and these 2 angles, when they're added up, they equal this exterior angle here. So this is 40 plus 90. This is 70 plus 70. This is 35 plus 120. And again, that's just the theorem and the rules that were discussed in our Think Up Math book earlier this week, that these remote interior angles will be equal to the exterior angle. And again, if you look at this like without looking at it as a triangle, you'll see that this is 180 degrees. So 50 plus 30 is 180. 155 plus 25 is 180. 40 plus 140 is 180. And they want you to look at the relationship here. This is W and this is Z. And in all of my answers, it's asking about finding W, but you must use these 2 angles out here. Let me make this look like a Z and not a 2. All right. So over here, same situation. They give you 4 pictures and they want you to figure out, well, what should X be? So here, this is 70 and this is 70 because these are the same angles, they're corresponding. Here, this is a right angle and a right angle. Here, this is 110 and 110. They want to know what is X. So based on these other pictures here, what is the relationship that they're showing between the angles that they have labeled and given measures to? That's the same application they want you to do here. All right, looking at number 3. So in Skyward, I listed this question as 3A, B, C, D, E, F, G, and H. So all of these go with question 3. So first they want alternate exterior angles. Remember, alternate means opposite sides of the transversal. An exterior means outside. So this is my exterior over here. Exterior, 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 and exterior. This is my interior and interior. Okay, it's like a sandwich. And exterior angles are my bread. Interior is my meat or cheese or whatever you want to put your peanut butter, your jelly inside the sandwich. So if I'm looking at alternate, when you alternate hands, you're using your left, then your right, then your left, then your right. So I want alternate sides of the transversal, and I want them to be on the outside. So I need to look at these out here and see which ones are outside and which ones alternate. All right, so I think you can figure out, which angles are alternate exterior angles. Then it says, give an example of corresponding angles. Remember, corresponding angles have matching corners. Kind of like these up here. So if this is 70 degrees and this is 70 degrees, if this is 90 degrees and this is also 90 degrees, these are corresponding angles. Their corners match. They're not exactly in the same place, but they look exactly alike. All right, give an example of vertical angles. So those are the kissing V's. That's what I like to call it. It's when you can't see my hands, but when you're two angles across from each other, excuse me, are equivalent. So like 1 is equivalent to 2 and 3 is equivalent to 4. So over here you would look at this like an X, and then you would have your vertical angles. So there and there. Those are examples. All right, give an example of alternate interior angles. Remember, alternate means opposite sides of the transversal. Interior is just on the inside now. Now we want the opposite of that. We want same side interior angles again. So they're on the interior and they're on the same side of the transversal. This answer will not look like this answer, okay? I will give you a hint here. One number should be even and one number should be odd. One even and one odd. That's the name of the angle, like 4, 5, 6, 7, 8, 9, 10, 11, 12. One even and one odd from this situation, though. And over here, you're going to name 2 evens or 2 odds, not both. Okay? Give an example of supplementary angles. So these are angles that add up to 180 degrees when they're added together. They form a straight line. Give an example of a linear pair. The angles that you put here could very well be the ones that you put here, but these angles have to share a side. And then give an example of 2 congruent angles. Again, vertical angles are congruent, corresponding angles are congruent. You can go any way you want with this answer here. All right, number 4. Oh, this is number 4. I gave you number 4 in Skyward. They just want us to prove whether or not these are similar. So if this is 105 degrees, then this should be 105 degrees too because of the indicator here. But if we add 43, 105, and 34, we should get 180 degrees because that's the total of the inside of a triangle. And if 2 triangles are similar, then 2 of their angles must be congruent. But if we add these up, this is not going to give us 180 because 3 plus 4 is 7 plus 5 is 12. And this is 8 and 1. This gives us 182 degrees, which does not equal 180. So this is not similar. Okay. All right, now on to the next page. Okay, here it says to find the value of x. These 2 angles right here lie on a straight line. Okay. I have seen a lot of confusion where you guys want to make these equal, but truthfully, this angle is acute and this one is obtuse. So there's no way that they could be equal unless this was a straight up or down line and this transversal was perpendicular with both these parallel lines. So for that reason, I must set this expression and this expression, add them together to equal 180 degrees. All right, so now that I've set it up, I have this angle plus this angle equals 180 degrees. Now I'm going to solve for x. Solve for x. And in order to do that, I need to combine like terms. So those x's need to be combined, and then these constants need to be combined. And don't forget that that is a negative 9, not just a 9. So if I do 12x plus 22x, that is 34x. And then if I do 19 plus negative 9, that's 19 minus 9, which is 10, which equals 180. So now this is a two-step equation, and you should be able to solve from here. Now we're going to do the same thing over here, but the difference between number 5 and number 6 is number 5 just wants x, but number 6 wants x and the angles, okay? So if we use the parallel lines that are cut by the transversal, we should see that 10x minus 20 and 7x plus 4 are alternate exterior angles. Hint, hint, alternate exterior angles. Okay, they're on opposite sides of the transversal, and they're on the exterior. Exterior, exterior. This is also the exterior, this is also the exterior, and the inside of the sandwich is right here. Okay, so these two angles, alternate exterior angles, are congruent, meaning their measures are the same. So I'm going to set these equal to each other. 10x minus 20 equals 7x plus 4. Again, I'm still combining like terms, but now I'm moving one over the equal sign and then a constant over the equal sign. So I must make it the opposite. So I'm going to subtract 7x from both sides. And then I'm going to add 20 to both sides. I'm doing this in one sweep. Then I have my 20s over here, cancel out. 10x minus 7x is 3x, and 4 plus 20 equals 24. Now you should be able to solve this last step to find x, and then once you found x, you're going to plug it back in to figure out what the measure of this angle is. So it'll be 10 times whatever x is minus 20. And you should get the same thing because they're equal if you do 7 times whatever number plus 4. All right, down here we've got some remote interior angles, and they're going to equal the ones on the outside. So angle 1 is equal to the angles that are opposite from it. Boom, bam. Angle 2 is equal to the angles that are opposite from it, meaning they don't touch it. Angle 1 does not touch these two. Angle 2 does not touch these two down here. And angle 3 does not touch these two up here. I can also look at this like a straight line. This is 70 degrees. So how much more do I need to get to 180 for angle 2? This is 60 degrees. How much more do I need to get to make a straight line? And this is 50 degrees. How much more do I need to get to a straight line? So there's several different ways that you can find angle 1, 2, and 3. Here, this is a review. We just did problems like this up here. Okay? Combine like terms. Simplify. Combine like terms. Simplify. Combine like terms. And simplify. Lastly, label which transformation happened algebraically. These come straight from your transformation notes. STRAIGHT, straight from transformation rules in Google Classroom. Okay. Good luck.